Good morning, students. In today's class, I will explain about the different storage classes in C++. The concept of storage classes you already learned in C programming. The different storage classes are available in C language are available in C++ also. In our last class, we learned about what are reference variables. Reference variables are nothing but alternate name or alias for the original variable. So, original variable can be called by another name. So, the another name we call it a reference variable for the original variable. We also studied what are the applications or uses of reference variable. Reference variable allow us to refer a memory location by two different names without wasting the memory for each. And we learned the major difference between a pointer variable and a reference variable. A pointer variable holds the address of another variable. Hence, a pointer variable and its original variable will have different addresses. Whereas, since a reference variable points to the same memory location, the original variable and its reference have the same memory address. In today's class, we will be learning about the different storage classes available in C++ and the meaning of the term scope and longevity of a variable. After attending today's class, you will be understand the different storage classes available in C++. What are the major differences among the various storage classes? And also, we are going to learn about the meaning of the terms scope and longevity of a variable. Storage class tells you till what part of the program the variable is accessible, whether the variable is available only accessible within a particular function or whether the variable is accessible throughout the program. So the accessibility of a variable is decided based on the storage class. Any variable you declare in C++ must belongs to one of these storage classes. It could be an auto variable, extern, static, and register. So these are the four different storage classes available in C++. The same storage classes are available in C language also. So with respect to storage classes, there is no difference between C and C++. Let us start the storage classes one by one. The first storage class is auto storage class. It's also called as automatic storage classes. So automatic storage class is one, any variable declared inside a function is said to belongs to the storage class auto. So a variable declared inside a particular function, we also call it as a local variable. So local variable and automatic variables are one and the same. One characteristics of an automatic variable is it is created when you call that function. When the moment you leave the function, the variable is destroyed. So during when you call it, it creates the variable. When you leave that function, when you quit that function, the variable is destroyed. So before leaving the function, it will destroy the variable and the control returns back to the calling function. Automatic variables are generally private to a particular function because that variable cannot be used or cannot be accessed by any other function. So every function has its own variable which is declared inside that particular function. So those variables declared inside a particular function are nothing but private variable or automatic variables. For any variable, if you don't mention the storage class, if you just tell the data type and the variable name, in that case, the variable declared without mentioning any storage class is said to be a auto class or automatic variables. So the default storage class in C++ is automatic storage class. And since they are declared inside a particular function, they are restricted. The usage of that variable is restricted to the block inside which it is declared. So if you declare any variable inside a function called f, then that variable can be used only within that function. Outside the function f, it has no meaning. Similarly, if you declare some other variable inside a function called f1, then those variable declared inside f1 can be accessed only within f1. So the variable declared inside f cannot be accessed by f1. The variable declared inside f1 cannot be accessed by f also. Since a main function is also one of the function in C++, any variable declared inside a main function is accessible only to main function. So variable declared inside a main function cannot be accessed by any other function like f1, f2, f, etc. Let us take one simple example illustrating automatic variable. Void main int a comma b. So here inside the main function, I declared two variables of integer type called a and b, and I have not mentioned any storage classes. In that case, a and b are said to be of auto class. And the prototype void f void indicates that I will call a function called f with no argument and no return value. So the initial values of the automatic variable a and b are set to 10 and 20 respectively. You display the value of a and b. On the moment you declare the values of a and b, then the output will be 10 and 20. So you can see the output. The output is 10 and 20. After that, I will call a function called f. When the moment you call a function, the control jumps to the function f. So here main is a calling function and f is a called function. Inside f, I will declare another variable called x of integer type with an initial value equal to 5. So there explicitly I mentioned the storage class as auto. If you don't write anything also, it is automatic. But if you want, you can mention it explicitly with the keyword auto. So x plus plus, x is incremented by 1. So x becomes now 6. Then display the value of x. Now it will be 6. So the second line of the output is 6. After that, the control, you are leaving the function means when the moment you quit the function called f, the variable x which is declared inside the f will be destroyed. So when the moment you leave the function f, x will be destroyed, and after that you cannot use the variable x. Then again, I will return the calling, the control returns to the calling function, then a plus plus. So the automatic variable a is now becomes 11. Similarly, b minus minus means b becomes 19. Again, display the value of a and b. The output will be 11 and 19. So in this example, we can learn that the variable a and b declared inside the main function are local variable for main function. Similarly, the variable x declared inside the function f will be a local variable for f. X cannot be used by main function and a and b cannot be used by f function. So in the main function a and b, I have not mentioned the storage class, still they are considered as automatic. Whereas for x, explicitly I have mentioned the storage class with the keyword auto. So x is also automatic variable. The second storage class is external. Automatic variable is one, the variables are declared inside a function. But if you declare any variable outside of all the function, such variables are called as external variable. The external variable can be accessed by any function because they are not declared inside any particular function. They are declared outside of all the function. Since they are declared outside of all the function, they are considered as global variable. Another major difference between an auto storage class and external storage class is automatic variables are alive and active within a function, whereas external variables are alive and active throughout the program. So the activeness and aliveness, longevity of an external variable is more than the longevity of a automatic variable. So since automatic external variable have a longer duration, longer longevity, they are declared outside a particular function. And generally, external variable, you have to declare it using a keyword called external. For automatic, even if you don't write auto also, it is considered auto. But for external variable, you have to declare it using the keyword called external. So this example illustrates the usage of external variable. So external int x equal to 0. Here, I have declared a variable called x of integer type outside both the function, outside main and also outside f. In that case, x is considered as an external variable. So the prototype void f indicates that the function f takes no argument, return no variable, no output, and see out x. So x becomes 10. The first line of the output is 10. After that, we are calling the function called f. So when the moment you call the function, the control jumps to the function f. Inside that one, I'm again writing x equal to 20. So here what happens is, since x is declared outside main, x can be accessed even by the function f. So f function also has the power to access the variable x. So inside the function f, I will change the value of x to 20. So see out x. the output will be 20. The second line of the output will be 20. After that, I will quit the function f, and the control returns to the main function. There again, x plus plus, because x is a global variable. Main also can change the value, f also can change the value. So x becomes now 11. X becomes, oh. So after the x plus plus means already the function f has changed the value of x to 20. So x plus plus means x becomes now 21. Then see out x, it will be 21. So external variable can be accessed and modified by every function in the program. They're not limited to any one particular function. The third type of storage class is static variable. So static variables are declared using the keyword called static. But the one characteristics of a static variable is if you declare any variable with the keyword static inside a particular function, it is considered as it's considered as a local static variable. If you declare any static variable outside a particular function, outside of all the function, it is considered as a global static variable. So one characteristics of a static variable is a static variable persists till the end of the program. So that variable remain existent till the end of the program. And a static variable, another characteristic is it is initialized only once. What do you mean by initialization? The place of declaring and giving some initial value to the variable, that declaration we call it as an initialization. For static variable, initialization takes place always once. And even if you don't give any initial value also, static variable by default will have the initial value 0. So these are the three main characteristics of a static variable. They are by default, their initial value will be 0, and they are initialized only once, and they retain the value or they persist till the end of the program. So let us consider another example illustrating static variable. So void main, inside the main function, I declare a variable called I of integer type without mentioning the storage class. In that case, I is said to be belongs to the storage class auto. The prototype, the function already explained in the previous two examples. Then I will for I equal to 1, I less than or equal to 3, I plus plus, call the function f mean. When I equal to 1, you call the function f. When I becomes 2, you call the function again. When I become 3, you call the function f. So you are calling the function f inside the main function 3 times. So when I equal to 1, when you call the function f, the control jumps to function f. Inside that one, I will declare a variable called in x equal to 0 and with the keyword static. In that case, yes, x is considered as a static variable. So that line static int equal to 0 is considered as an initialization line. So for static variable, that line is executed only once. Even when you call the function 3 times also, only when you call the function first time, that line is executed. Second time onward, it executes the statement x plus plus onwards. So first time static int equal to x equal to 0 means x value will be 0, x plus plus, x becomes now 1, display the value of x. So x value will be 1. Then you are leaving the function, then automatically I takes the next value equal to 2. Again, you call the function called f. The control again go to the function f, but the line static int equal to x will not be executed because the initialization takes place only once. Then another characteristics of a static variable is it retains its previous value before you call the function. First time when you leave the function, its value will be 1. So it retains its value. Then next time onward, if you write x plus plus, it will change the previous value. So from 1, x value becomes 2, display the value of x. Again, output will be 2. Return back to the calling function main. Then I becomes 3. Again, you call the function f. Then again, static int x equal to x, 0 is not executed. Before leaving the function only, x value was 2. Now x plus plus means x becomes 3. Display the value of x, 3. So one difference you can note down here. If you don't use the word called static in the line static int equal to 0, if you don't use the word static, in that case, x is considered as an automatic variable. In that case, the output will be when I equal to 1, call the function f, the control goes there, int x equal to 0 means x becomes 0, x plus plus, x becomes 1, display it 1. Then if it is a static variable, before you leave the function, x is destroyed. Then next time I becomes 2 means again if you call the function, again x is created with initial value 0 only. Again x plus plus means x becomes 1. So if second time also the output will be 1 only. Third time also the output will be 1. So If by adding the keyword static, you are getting the output 1, 2, 3. If you don't use the word static, your output will be 1, 1, 1. So that is a major difference between a static variable and an automatic variable. Automatic variable, each time when you call a function, it is created. Each time when you quit the function, it is destroyed. Whereas a static variable persists till the end of the program. And for static variable, the initialization takes place only once, and it always retains the previous value before leaving the function. The last type of storage class is register variable. There is a difference between auto, static, then external and register. The first three category, auto, static and external variable, the variables are stored in memory location. Whereas if you declare any variable with the storage class register main, then it is stored in memory computer register instead of memory location. Then what is a register? A register is also one type of storage only. The difference between a memory variable and a register variable is generally the processor looks for the value of the variable first in the register. If it is not available in the register main, then it searches in the memory location. So static, auto, extern, the value of the variable is stored in memory location. Whereas for register, it is stored in compute CPU register instead of memory location. Since the processor always checks for the value of the variable in the register, the time to access register variable is less when compared to time to access the variable if it is stored in memory variable. So the memory variable takes more time for searching because the processor first has to search the register. If not available, then it will search it in the memory location. The question is, why can't we store all the variable in the register variable? No, it is not possible because every computer, the number of registers are very, very limited. Only 5 registers, 6 registers, 10 registers. If in your program, if you have some 20 variable, all the 20 variable, I cannot make it as a register variable. What you do is, the most frequently accessing variable, you store it in register. Once the registers are exhausted, once all the registers are filled, then remaining variable, you store it in the memory variables, memory locations only. But if you are in your program, if you have 20 variable and your computer has only 5 register, in that case, even if you declare all the 20 variables as register variable also, there is no capacity in the register because the number of available register, if it is only 5 mean, even if your program has 20 variable also, even if you declare it as a register variable also, what your processor will do it will store only the 5 variable in the register. Once all the registers are filled, then the remaining 15 variable are stored in memory location. Even if I mention it as register variable also, if there is no provision for you to store it in the register, it will be stored it in the memory location only. So this example illustrates the usage of register variable. Register int x equal to x. In that case, the value of 8 that is stored in the variable x. Now x is stored in register instead of memory location. Next term, cout x means the processor checks for the register. If the value of x is available in the register, display it. If not available, then it will go for memory location. But in this example, only one variable is there. Then no problem. It will be considered as a register variable only. So before concluding, I want you to define two more terms which are associated with a variable. One is scope of a variable, other one is longevity of a variable. The scope of a variable determines over what part of the program the variable is available for use. If you declare any variable inside a function, then that variable is available for use only within that function. So the scope of such variable is limited. If you declare some variable outside of all the function means that variable is available for usage throughout the program. That means the scope of the global variable is more than the scope of the local variable. The second term is longevity of a variable. Again, longevity refers to the duration or the period during which a variable retains a value during the execution of the program. That means till what time the variable retains its value. If you declare a variable as a automatic variable, what happens is the value of that variable will be retained as long as you are inside the function. When the moment you quit the function, the value will be destroyed. So the longevity of the automatic variable is very, very short duration, whereas the longevity of an external variable is more. So I think you understood the term called scope of variable. For automatic variable, scope is also less, longevity is also less. Whereas for external variable, the scope is also more because that variable can be used throughout the program. And longevity is also more because the variable, the value will be preserved till you leave the program. So as long as you are inside the program, that variable will be active. Whereas for automatic variable, when the moment you quit the function, the value will be destroyed. So the duration in which the value of the variable will be preserved is very, very less. So based on today's class, I have framed some important questions on the topic storage classes. Explain the different storage classes with example. Compare and contrast auto and external. One is local, other one is global. Write a note on register variable. Define the term, scope and longevity of a variable. Let us revise what we have studied through some simple multiple choice question. Dash is known as a local variable. Another name for a local variable is automatic variable or auto. The correct answer is B. Dash retain its value during successive function call. Automatic variable cannot retain its value because when the moment you quit the function, the variable will destroyed. So static variable retain its value during successive function call. The correct answer is D. Dash has the widest scope. Auto, global, static, none of these. The correct answer is B. Frequently accessed variables are declared with dash storage class. So any variable, if you are using it very, very frequently, if you store it in register, then the time to fetch that variable is, the time is less. So it is, the correct answer is register or D. Default value of a static variable, already I told, for any variable, if you mention the storage class as static, and if you don't mention any initial value also, by default, its initial value will be 0, especially for static variable. The correct answer is B. Okay, students, in today's class, we learned about what are storage classes, what are all the available storage classes in C, and what is the meaning of the term scope and longevity of a variable, and how to use the different storage classes in a program, and what is the major difference between auto, static, extern, and register variable. Because the first three, the value of the variable is stored in memory location. For register variable, it is stored in CPU register. So with this, I will conclude today's session. Thank you.